Good morning, everyone, and welcome to this workshop about 5G telco cloud service orchestration. Um, you are joining today in an event that is being organized by Digital Catapult as part of its participation and contribution in several R&D projects in the 5G space, and more specifically, Horizon 2020 5G VICTORI project, and also in the 5G Factory of the Future funded by the Department for Digital Culture, Media and Sport in the UK. My name is Dritan Kaleshi. I am Director for 5G at Digital Catapult, and it is an absolute pleasure for me to open this workshop today, looking more specifically in certain aspects of a very important topic and a very advanced topic, which is orchestration. Before we get going, some very quick and brief housekeeping for you all. The session will be recorded. This webinar is being recorded. The recording will be available on the Digital Catapult YouTube channel in the next, it will be made available in the next few days. For all of the participants, you'll have a chance to ask questions throughout the event. So please submit these questions as usually in Zoom sessions in the question and answers box, which is at the bottom of your screens in your Zoom window. The chat box is also open for any comments and discussions that you wish to have throughout the event. And by all means, please contact us if there is any chance that some of the questions will not be answered during the webinar itself. Please contact us as organizers as well as the speakers individually later on. So looking at the agenda for today, we have a packed agenda. The initial welcome is by myself, but then we will be looking at a keynote on telco cloud orchestration delivered by Kostas Katsaros, lead 5G technologist at Digital Catapult. And then we will go into several presentations on from industry and Digital Catapult around service orchestration across multiple edge sites, delivered by Melissa Dore, Vice President for Community for Auri. IBM's Cloud Pack for network automation, delivered by Kevin Denier, a Global Account CTO at IBM, and Open Source Mano from Charles Turiagenda, which is a lead 5G technologist at Digital Catapult. Then there will be an open discussion chaired by Claire Caminat, Head of 5G Products and Partnerships for 5G at Digital Catapult. And at the end of the webinar, after a break, you'll be able to see 3 virtually delivered demos from 5G VICTORI infrastructure operating system, 5G VIOS, on IBM Cloud Pack for network automation, and also on open source Mano and how that is being used in 5G Factory of the Future, with concluding remarks at the end of the day. We effectively wish you to have a very, very good and productive day. For us, it's particularly exciting to effectively look at this technical workshop addressing some very, very specific topics around orchestration. For us at Digital Catapult and more broadly in the industry, orchestration is one of the key features of advanced digital infrastructure, of which 5G is a perfect example in terms of facilitating a more flexible digital infrastructure to enable digitalization in vertical industries. It is a very, very strongly related topic, not only in delivering automated services into large-scale national level mobile network operator owned infrastructure, but it is equally important and potentially more easily deployable and the benefits more easily realizable in the private network space, which is particularly important in vertical industries like manufacturing, transport, logistics, healthcare, and the others. And it is in this space that we will be giving some examples of some of the very cutting edge aspects of orchestration and how orchestration in different contexts is addressing specific challenges around automation and services, both by industry, as will be presented by Auri and IBM, as well as on the R&D space. For example, on how service orchestration will be able to work across interdomain, or what we at Digital Catapult call interdomain orchestration, which is particularly important for interconnected 5G private networks, and other topics in this space. And without further ado, I welcome everyone into this webinar, and I pass on now for the keynote presentation for today to Dr. Kostas Katsaros, lead technologist for 5G at Digital Catapult. Kostas, over to you.
Thank you, Dritan, and welcome everyone to this webinar. My name is Kostas Katsaros. I'm a lead technologist at Digital Catapult, and today's presentation is how 5G VIOS, our VICTORI infrastructure operating system platform, enables inter-domain orchestration. So an overview for this presentation, I will try to introduce basically the concept of telco cloud service orchestration, what it is, why it is needed, and some elements on how this is done generically, and then dive into details of how we approach this challenge in 5G VICTORI project with the 5G VIOS platform. So as we are seeing a new era for wireless telecommunication, an era that is transforming the way that business is done. With the advent of 5G communication, systems we're experiencing a convergence of various networks and information systems, namely cloud computing. With support for higher capacity as well as ultra low latency and machine type communication services, 5G networks will significantly improve performance over the current fourth generation systems. Will also offer seamless connectivity to numerous devices by integrating different technologies, intelligence, and flexibility. And as Dritan said, link different private networks that currently mushroom up, especially for enterprise networks. One of the key verticals that 5G is going to transform is the telecommunication industry itself. Current 4G systems are based on monolithic centralized architectures on top of specialized hardware, which incurs high capital and operational expenditure for operators and are complicated to upgrade. The 5G specification introduced a radical change to the network architecture, enabling infrastructure virtualization and slicing at network or service layers. Key enabling technologies for 5G transformation are software-defined networking, SDN, and network function virtualization, NFV. NFV significantly reduces CapEx required, as network functions can be delivered by commodity hardware rather than bespoke. In principle, NFV enables delivery of cost-effective networking slices at the compute and physical resource level. NFV is also key to deliver edge computing services, whereby application services as well as network functions are deployed closer to the user in order to provide low latency, increased security, and other elements around that. In addition, open networks and Open RAN in particular is an area of considerable interest and activity with huge potential, and it will be key for the future of networking and opportunities for innovators in the UK and beyond. We see that Open RAN is based also on softwareized infrastructure that is distributed and requires management across different networks and infrastructures. The evolution of NFV has led to the adoption of containers, primarily due to the large ecosystem of developers using Docker and Kubernetes. More and more telco vendors and network operators are partnering with cloud providers and hyperscalers like AWS and Google Cloud that offer a platform to help their customers monetize the investments in the network, benefiting developers and businesses. The experience and tools that have been used in cloud operation for many years, such as DevOps and automation, is being brought into the networks. The new management and orchestration layer, this MANO system, has been introduced and standardized to manage the virtualized resources, compute and network resources. This enables the acceleration of enterprise digitalization with the development of programmable APIs that are exploited by enterprises to gain insights and visibility to their infrastructure. By standardizing network slice lifecycle management, resource delivery, and connectivity, vendors and operators can develop novel services, solutions at scale rapidly, cheaply, and effectively. These services can be consumed by themselves or exported to third parties like the enterprises. Imagine putting the power and capabilities of 5G, the biggest global innovation platform that we have at this stage, at the fingertips of developers and your ecosystem. We see that more and more operators embark to telco journey. A recent study from STL Partners shows the number of deployments of telco cloud and different technologies around telco cloud in the recent years. Most deployments are related with introduction of 5G core in the last couple of years, edge computing, and software-defined wide area networks, SD-WAN. There are some deployments of Mano platforms and some that will come in. We would expect edge and Mano to increase as edge computing increases, and the fact that private networks will take up and require more orchestration. What are the challenges and benefits for network virtualization and generally telco cloud? As I mentioned, by using and virtualizing your network functions, you are able to use vendor agnostic white boxes instead of fixed function proprietary hardware. This increases the vendor options that you may have and potentially reduce the cost that you have. You also require network visibility. By having centralized network control and monitoring, you can enable automation. You can then include an AI and machine learning optimization platforms in your orchestration platform in order to improve the operation of your network. The introduction of edge computing and the decentralization of the networks puts workloads and networks distributes them across multiple domains. This is quite a challenge to manage them. However, this will enable reduction of latency and the backhaul requirements, and potentially increase the security and compliance that several enterprises may have in order to keep the data within the boundaries of their systems and the networks. One of the projects that we are working on to apply those principles of Mano system for multi-domain orchestration is 5G VICTORI. 5G VICTORI is one of the Horizon 2020 ICT 19 projects working on vertical application for 5G, exploiting infrastructures developed by other projects. The top objectives for 5G VICTORI are the following: to design and prototype an open 5G infrastructure capable of instantiating and co-hosting various vertical sectors, integrate commercially relevant operational environments required for the demonstration of large variety of verticals and cross-vertical use cases, and finally, transform current closed and purposefully developed and dedicated infrastructure into this open environment where resources and functions are exposed to the telco and the vertical industries through common repositories. The objectives have been developed into the 5G concept, which are described here, basically are depicted in this high-level reference architecture. We have 4 key facilities, as we call them, so 4 private networks and testbeds across Europe, and they are linked through this multi-site inventory and multi-site orchestration platform, on top of which cross-facility vertical services are being deployed. We call this multi-site orchestration platform 5G VIOS, VICTORI operating system, which enables and links with 3GPP in several elements and links and enables inter-domain orchestration. Now, on top of these facilities, the 5G VIOS is exposing the resources and the network services through common repository that can be accessed through APIs and the portal in order to transform current closed, purposely developed infrastructures into open environments. With the development of this thin interdomain orchestration layer on top of each infrastructure and facility, network services can be brokered in order to form network services that span across multiple facilities and multiple networks and domains. A comprehensive open data management platform enables the collection and analysis of data that can be fed into machine learning AI algorithms for optimization of the network services and resources and network in order to then improve the deployment of future services on the same infrastructure. Now, looking into more deeply into the 5G VICTORI infrastructure, its facility is based on this reference architecture with the management and orchestration system controlling the underlying virtual network functions, physical network functions, and the whole virtualization infrastructure. 5G VICTORI is built on the concept of this common thin layer orchestration platform, which we call 5G VIOS. Different approaches for this multi-domain orchestration have been proposed, and we'll see today different solutions either from industry or from open source, like open source Mano, in order to do either a hierarchical brokering of services or a federated control across different peer orchestrators. To support this thin cross-domain orchestration, the brokering approach has been adopted in 5G VIOS. Many solutions provide monitoring of data, and particularly the network KPIs that are simply fed into a form of a dashboard. Very little is done in order to actually analyze and use that data with machine learning algorithms to improve the operation and deployment of new services. Now let's see more details on how 5G VIOS is deployed and what it can do. 5G VIOS, you can see on top, is based on a common service bus and a service-based architecture with several microservices deployed as containers. So following the concept of 5G service-based architecture, it enables the connection and brokering of multiple sites across the facility, the 5G VICTORI project. It provides access to functions and repositories that are available in different facilities. And this service-based architecture is aligned with 3GPP reference architecture. It provides the necessary network resources for interconnecting network functions using the appropriate interface like N32 for control messages and N9 for tunneling user plane functions directly between different networks, 5G networks. Based on the Xbox functions, various deployment options can be supported. We see here an example where 5G VIOS can be deployed, for example, in a third-party hyperscale cloud. And we have the 4 different facilities in the project, namely the testbed in UK, the 5G UK in Bristol, the testbed from 5G Vini in Patras, the testbed from 5G Genesis in Berlin, and the testbed from 5G Eve project in Alba Iulia. They are interconnected using these DMVPNs, the dynamic multi-point VPN service, which enables the connection between the 5G VIOS hub and the different spokes, and enables also hub to spoke and spoke to spoke interconnections. Now, how an end user can basically make use of this facility and how this is open to the end user. So we call experiments what normally can be seen as a service that is deployed as an end user application, because we are an R&D project and we want to run certain experiments and then collect trial results and do an analysis. So the first step that an end user will have to do is to define what he needs for his experiment. So define what network services he would like to use, what the network slices, his performance targets and SLAs and scenarios that he wants to run. We have developed a graphical interface, a portal, where this can be easily input to the platform. Then the platform, 5G VIOS platform, is creating that experiment and translating the input from the end user to what is machine interpretable language, basically what will be used later by the orchestration platform and to deploy the services. So you are able then to select the different nodes and the different facilities that you want to run. You modify and configure your slice and also build and compose your interdomain network service when there is a need for interdomain network service. Then the next step is to actually deploy the experiment, deploy the service on the different infrastructures that you need. So using machine learning and the profiling platform that the University of Bristol has been building, optimal resources can be calculated in order to deploy that network service. Then network service is instantiated and deployed on the different infrastructures, and the right resources are being allocated for that network service. During the deployment and actual running of the service, you are able to collect network and resource data, analyze them, and present them to the end user for future scenarios, or basically feed them back to your machine learning algorithm in order to improve future deployments of services. This is basically the wrap-up of my presentation, and this is more details about how 5G VIOS is being used and how you can deploy an interdomain network service will be demonstrated later by Mark Rouse in our demo session. So any questions from you at this stage? If not, then we move to the future presentations. So we have, as described, 3 presentations. One starting with Melissa Dorr on service orchestration across multiple edge sites from Auri. Then we will move in with Kevin on IBM's Cloud Pack, and we will conclude the presentation with open source Mano from Charles Tiragenda from Digital Catapult. So Melissa, please. So let me stop sharing and you can start.
We actually had a little question pop up. What does VIOS stand for?
I explained that in the presentation. Sorry. It was the VICTORI infrastructure operating system. Yes, that's.
Oh, sorry, I thought it was a new one.
Yeah, you know, in 5G, we are keen to have new acronyms every time. So yeah.
I love trendy acronyms. So. Yeah. Amazing. I'm just going to present my slides. Amazing.
Yes, that's good. Thank you very much, Melissa.
Thank you so much to everyone at the Digital Catapult for inviting us along. I'm going to be talking to you today about service orchestration across multiple edge sites. So I'm Melissa Doré. I'm the VP of Partnerships and Alliances at Auri. I also look after our brilliant community of edge native thinkers and innovators. And yeah, really excited to speak to you today. So the current state of IT is very challenging. There's an overwhelming number of options available for enterprises to choose from. Beyond just software, there are deployments across public and private clouds, internal data centers, hosted data centers, edge locations to choose from. The list goes on. The location of this hardware increases the complexity of the situation, as not all data can be moved between countries, and global customers demand fast, on-demand access. So this means that telcos are having to make very large investments to support all of these different requirements. And this is specifically in 5G now and mobile edge compute. Meanwhile, they face market challenges and forces outside of their control. So we've seen lots of different changes in how the market's working from the hyperscaler side. They've got an increased amount of competition And also they've got to manage their legacy infrastructure and make sure that they're, upgrading that, and that's extremely costly. All the while looking at how they can cost cut, because things are moving so quickly these days, those investments need to move very fast. So all of this means that we've got increasing infrastructure complexity, and mobile operators are working very hard to think about how they can generate new revenues and monetize 5G services. So that's kind of where we are now. So we're looking at how there's an increased need for visibility and control across global application deployments, all at a lower cost. Operators need a single pane of glass management platform for heterogeneous and distributed infrastructure that runs from cloud to on-premise. And we've also seen that we want a simplicity of connectivity, ideally with a user and data plane that runs from on-premise edge to public cloud, all while leveraging existing network infrastructure. We also need data locality to meet data protection regulations for processing and storing of data. So what's happening in the meantime is we have edge potentially bringing a 90% savings across industries overall. So this is really where the edge opportunity is for us. And that's why we built Auri Global Edge. So Auri Global Edge is a distributed cloud computing platform for mobile operators. It gives them the ability to run cloud native everywhere through a single management, control, and user plane that brings a SaaS cloud operating model to infrastructure and applications deployed to any edge location. Think multi-cloud without complex integration. Also running applications anywhere. We need a new way to deliver applications with unparalleled performance and security at a global scale, without having to worry about physical servers or complex infrastructure management. We also need to monetize that edge infrastructure. So you can monetize your MEC through Auri Global Edge, but by driving agility and simplifying application orchestration across your distributed sites. You can also create your own infrastructure solutions through the cloud portal. So this is all happening through one intuitive platform. We want to be reducing the complexity of service orchestration across multiple edge sites. Through the platform, users can provision, manage, and scale the infrastructure available to them dynamically and seamlessly. The application also allows you to manage the quality of service and delivers the performance you need without having to worry about the infrastructure integrations underneath. This is all through the Auri Global Edge platform, which has 3 primary layers. So these layers sit on top of commonly deployed infrastructure, and the Auri portal is actually the UI on top. That's for management of all services available within the platform. So for managing global application deployment and management. The service layer enables application features for orchestration and management on a lower level. The management layer is actually our internal Auri Global Edge management services, so how we make it all happen. And the infrastructure layer is the underlying virtual and physical infrastructure that we integrate to. So the service layer allows the running of applications anywhere, with infrastructure administration, meaning zero-touch provisioning of infrastructure from multi-access edge compute to different cloud providers or on-premise private infrastructure such as VMware or OpenStack. With workload orchestration, you have simplified application deployment and management, which means that we abstract and manage the control plane, geography, security, DNS, and load balancing so that you don't have to. Edge networking services mean that through our private backbone network, we connect and secure applications between on-premise and multi-cloud without having to go through the public internet, with intelligent traffic routing around failures to give guaranteed uptime and resiliency. All of this with identity and access management. So we're bringing industry best practices for user authentication and access control using zero-touch security and zero-trust security and architectures. Under this, we have the management layer. So the management layer allows the running of cloud-native technologies everywhere with multi-tenancy, meaning customers can securely run isolated projects spanning multiple edge cloud locations. Intelligent workload placement. So Auri Pilot deploys multi-tiered applications automatically based on specific requirements. Think GPU, location, processor type required. Secure networking is then the end-to-end secure fabric that provides connectivity between multiple local workloads and cloud points of presence, coupled with secure ingress for workload consumers, And all of this is supported with monitoring and logging. So think full visualization and monitoring tools for logs and metrics across your entire infrastructure and application estate. Finally, the infrastructure layer. So this is powering the OG solution by delivering virtualized infrastructure from providers like VMware, private clouds like OpenStack, or public cloud infrastructure as a service. So from GCP, AWS, or Azure, along with the physical compute, network, storage, and 5G services to the edge sites where the applications are actually running. So this virtualized and physical infrastructure. We can cloud enable your compute, networking, storage, fixed and mobile networking, such as 4G, LTE, and 5G, proprietary and open source technologies in order to virtualize your physical infrastructure. OpenStack and VMware private clouds and Kubernetes PaaS are compatible virtualized technologies over which the Auri Global Edge platform can run. Auri Net, which you can see underneath the physical infrastructure, is actually our central nervous system. So it's located in major internet exchanges. It provides the user and data plane connectivity between the edge sites and our OGE platform. Auri Net actually also provides the cloud infrastructure through which to run workloads, so it's ideal for highly connected applications. With Auri Net, you have your own global reach through our networked edge cloud. Finally, multi-cloud. Auri Global Edge interconnects with hyperscalers and extends its management, data, and control plane to it. So it's for running workloads on multi-cloud infrastructure. With Telco multi-access compute, we can also enable mobile operators to partner with other service providers and leverage their own MEC solutions. Edge is happening across multiple industry verticals that need highly available, highly resilient infrastructure to deploy to. So we've seen many different use cases across manufacturing, agri-tech, gaming and media, oil and gas. Think really remote locations or just very connected locations. You know, the needs are growing constantly across the industry. So the Edge is happening live today, and we'd love to work with you to deliver it. Thank you so much. I'd love any questions.
Thank you very much, Melissa. Is there any question for Melissa? I have one, if you don't mind. You mentioned about the Auri Edge Cloud and the link with the hyperscalers. Do you see that the Edge Cloud will be just to manage the hyperscalers, or is it replacing or competing with them?
I wouldn't say replacing or competing with. That's a pretty big piece of pie. I think it's very much, about how we can solve this growing amount of infrastructure. So we've seen many of our customers are actually looking at multi-cloud deployments simply for resiliency, so that they have the right level of security, etc. They run different services on different clouds. And so what they need is an ability to, manage all of that complex infrastructure in a seamless manner. There's always going to be a growing amount of different infrastructure that you need on site, in the cloud, in between. And so I think what we're actually building is complementary to that. We're just looking at how we can solve that complexity for the end user, which would be the enterprise kind of consuming that infrastructure.
Thank you very much, Melissa. Now let's move on with Kevin Denier on IBM's Cloud Pack for Network Automation. Hello, Kevin.
Thank you, Kostas. Great. Hello, everyone. Yeah, so my name is Kevin Denier from IBM, and I'm going to talk to you about our capabilities within IBM that we call the Cloud Pack for Network Automation. So there's some messages that we've heard from the previous two presenters, both from Kostas and from Melissa, this being the fundamental message in my mind that software is now becoming central to a modern telco network, and that's a big difference from the legacy of telcos, which was very hardware centric. If I was a telco operator, then I was working in that space, I needed to be a hardware engineer. With a modern network, that's swung completely to software capabilities which are running on commodity hardware, so not specialized hardware anymore, but commodity in many different locations, on the public cloud, at the edge, in data centers. And the interesting thing for me as well is that they've always been two different worlds. If I was a telco engineer, then I would behave in a very different fashion to someone that works in IT. My background is in IT, so I've been a software developer for most of my life. I've been a DevOps engineer as well, more recently, and I dabble in networks. And I think the opposite is true. People that have worked in telco their entire lives have dabbled in IT, and I think those two worlds are converging, and we can learn from each other. In particular, I think that this problem of software needing to be delivered and managed in order to run a telco network is something that has been solved and at least been worked on for many tens of years in the IT world. And there are things to be learned from that can be adapted and adopted and then used to manage and scale out networks. And these are, in my mind, are the sort of 4 areas. In particular, standardization to start with. So how do you deploy these capabilities in one way? Part of the pain of software delivery is that, and in particular to the cloud, is that not every cloud is the same. So your own private cloud compared to the different options that are there in the public cloud. If I deploy containers, for instance, into Google's cloud, it's different to the way that I would deploy that into Amazon's. How do I come up with a way of standardizing that approach so that I can deliver it in one way? And as part of that delivery, how do I take advantage of modern thinking around DevSecOps? Not to have that divide between the people that write code and the people that operate the code, but have that as a single process and have people trained and implementing software capabilities in that way. Automation is key to this. What you don't want to do is have teams and teams of people to do this. You want to have a small team that can manage very complex and scaled out architectures in the way that that would happen in software deployments today. If you think about something like Google and its search engine, there's a very small team that runs that, but it's a massive and complex set of infrastructure. You need to have that same capability in this telco space. And then finally, it needs to be cloud native. It needs to be using those modern capabilities. It needs to be containerized. It needs to run on Kubernetes, and it needs to be using all of those capabilities because it is going to run on all these different locations in the hyperscalers, at the edge, and in data centers. The reasons for this are obvious, and I've covered some of that as well. If you're scaling this out, we need to be able to deliver these things faster. There's no point in having 5G capabilities if you can't deliver them for the next few years. And we also, at the same time, need to reduce operational costs. If these new networks are delivered and they cost us more, we need to hire more people to manage them, then we're going in the wrong direction. And we need to have improved customer experiences as well to make sure that these services are used and appreciated. A couple of marketing stats around this. Talking to service providers in this space, 84% of them have identified that faster time to market is important to them. It's one of their most important KPIs. And 76% of them are also looking at those other 2 options of making sure that customer satisfaction is improved and that there is reduced OpEx. So it's definitely something which is shared by everyone that's operating in this space. So our approach to this is to do what I've said, really, is try and take the good things that we've learned over many tens of years of operating large-scale software deployments and use that capability in the telco space. And zero touch as an approach is all around control loops and automation. How do you discover things that are going on? How do you decide on what needs to be done about that? How do you then automate the actions of that to make change? And then how do you optimize that over time and then continue that in a loop? So you continually learn from what's happening. You're continually watching what's happening in the environment and making changes to improve that. When you take that kind of approach, and what we've seen from our production rollouts of these capabilities is that you do get those cost reductions. There's on general an 82% reduction in the cost of onboarding new services. And you do see that improvement in customer satisfaction, in particular, the reduction in the time it takes to respond to service issues. So how are we doing this? Couple of core things, really. And probably most importantly is the use of things like OpenShift and OpenStack. They are both Red Hat capabilities, which is an acquisition that IBM did coming up to 2 years ago now. So these are now IBM technologies, very important in this space. OpenStack for delivery of virtual servers and OpenShift for containerization. This is the way that, in particular, we come up with a standardized approach to deliver these capabilities anywhere. So run this on any cloud, any of the hyperscalers, you know, Google, Amazon, Microsoft, Ali Cloud, but less well-known ones as well, the Oracle Cloud, the SAP Cloud, Rackspace, but then all those other different locations as well, all of the edge locations, the ground stations, and the data center itself, including the way that you would test this and run this on your laptop and run this on a server in your garage if you want to. But let's have one way to deploy that everywhere. It's a common issue in IT. Having to test this when I have to deploy it in 15 different ways is a nightmare. So having a capability where I can deploy this in one way is incredibly important, and build all of the services on top of that. To go into a little bit of detail on what these services are in this platform, there are 5 of them. The first 3 I called day 1 capabilities. How do I build and orchestrate what's there? And then the second 2 on the right are day 2. How do I actually run and optimize this when it's up and running? And I'll show these capabilities when we go through a demonstration a little bit later. But it's very based on this left-hand side around modeling the actual life cycle of the components you need to deploy, having an orchestration engine which is intent-based, and I will cover definitely what that means a little bit later on, and a test capability as well to test this before you deploy it. Then once it's running, how do I use monitoring capabilities and artificial intelligence to detect where there are issues, resolve those before they happen, and also monitor the performance. These are then turning into personas really, and roles that are around this. And how do I manage a modern network today? And we start off with the network engineers using their subject matter expertise to build the models for what needs to be deployed. Have a standardized approach to that, use open standards for that as well, come up with templates, have an ecosystem of partners that generate all of those capabilities, and then use those as building blocks, jigsaw pieces that you put together. Is then given in step 2 here to a network service engineer as a role that then designs using those components to build a service, and then uses a testing suite to make sure that service meets the requirements, the non-functionals and the functionals. Then you move to using the orchestration engine to deliver this. And then we go into the day 2 operations where we have site reliability engineers that need the tooling and the capabilities to be able to watch these networks, test their performance, make sure they're available, and dynamically reconfigure them based on what's happening in those environments. Where's this in use? So, we've got many telco service providers that are using these capabilities. Here are some examples of things that are happening today with traditional networks. They're managing multiple network sites to standardize them and automate the builds of those. 4G and 5G rollouts of cores and RANs from a single set of templates and delivered in a single way. And then FEs and managing the life cycles of those. Plus also, more recent capabilities in terms of modern and new capabilities in networks as well. So 5G network slicing, I'm going to show a little bit of that in the demo later on. And these are really good examples of where these have been done on massive scales as well. So, definitely try to accommodate that cost reduction model by, if I have to deploy a 5G network to 1,000 sites, What I don't want is 100 people to be able to manage that. I should be able to do that with one click. VRANs and Open RANs examples, again, a really good example of where things have gone from being very hardware based to virtualized software and highly scaled. And then MECs as well. So this is a quick view on that day two. I will show this in the demonstration a bit later, but this is bringing in, again, capabilities from the IT space around observability, using in particular a product called Instana, which is part of our portfolio, to look at the live metrics of what's happening on the network, and then perform analysis on that and do real-time updates using the same orchestration platform to make change. So discover what's going on, figure out ways to improve the capabilities, and then deliver those using the same orchestration platform. Importantly, this needs the help of all of the vendors that are in this space. So also a lot of work around where, how do we create these standards? How do we create these templates and this lifecycle models? Using things like Mano, which Charles is going to talk about in a few minutes, using those open standards to build templates so that it makes it easier to manage this in a standardized way. And we have a large list of people that are involved in helping with creating those standards and those templates. So finally, why us? You may or may not know this, but 85% of the top 1,000 telecoms on the globe are our clients. We work very heavily with them. They've been reliant on our services for many years, especially in the data center space. So we're sort of in a good position to pass on those capabilities into telcos. And we have more than 450 subject matter experts globally working in this space as well. And I think to summarize, where we think we are bringing capabilities is bringing that maturity in IT into the software management of telcos, both in terms of AI, machine learning, analytics, and automation, but also our capabilities, which are fundamentally driven by our Red Hat portfolio, to enable you to manage things in a hybrid cloud, avoid a vendor lock-in, and do these in a standardized way. So on that, I'm happy to take questions before we move on to Charles.
Thank you very much, Kevin. I think we can keep the question for the open discussion session.
Right.
Let's move. So thank you, Kevin.
Thank you.
Charles?
Thank you, Kostas. Let me just share my screen and go through the slides. Can you see my screen?
Yes.
Okay, so in the next few minutes, I'll try to discuss at a very high level what open source Mano is. So it's the open source management and orchestration platform, and it's an open source initiative involving lots of people, operators, VNF developers, etc. So before we talk about orchestration, we need to understand one of the key drivers for orchestration, which is the virtualization. So virtualization proposes the use of generic hardware to replace commodity hardware. So all the things that we used to run on specialist hardware is now going to be run on custom off-the-shelf hardware. And why do we want this to happen? And this is mainly to make network operations more agile and cost-effective, and increase interdependency between functions from different vendors, and of course leverage all the benefits that that Kevin has been discussing about being cloud native. So these are some of the reasons why there's this shift towards virtualization and moving away from commodity hardware. The ultimate goal of virtualization is to have network functions from any single vendor running on a common hardware infrastructure. So, for example, we could have vendor one having a particular virtual network function with its corresponding element manager being run on the same physical infrastructure as vendor 2 or vendor 3. But how do we get to this point? And this raises the question of standardization, which again, other speakers have previously touched on. So we need a standard way of how we compose these network functions, the element managers, the virtualization infrastructure, etc. So we need a standard way of how we compose these virtualized functions. Within the ETSI NFV, ETSI Network Function Virtualization Framework, there's an architecture that has been proposed, and I'm sure most of you will be familiar with this, but the best way to understand this architecture is in 3 main building blocks. One is the actual network functions that we have that you would like to virtualize, and this could be anything from routing to, traffic steering, load balancing, even an entire 5G core network, the RAN network, etc. So these are the functions, the actual network functions that we would like to virtualize. Within this group, the virtual network functions most of the time come with their own element managers that help with the lifecycle operations of that particular function. Another set of modules within this ETSI NFV reference architecture is the infrastructure side. Now, the infrastructure side you can see is made up of the actual network function virtualization infrastructure, the NFVI, and the VIM, which is the virtualization infrastructure manager. A good example of this is if you take NFVI, which is general purpose compute, and you could have hypervisors in there like Zen, etc. And all of these could be orchestrated by, so all of this could be managed by a VIM, for example, OpenStack, and we will show some of this in the demonstration later on. So this is the infrastructure side of things. So this is the second set of components. Again, we would need some standard interfaces. For example, the NFVI interface between the VIM and the NFVI. This interface has to be well defined, so that when a particular VIM would like to deploy, certain virtual functions in this infrastructure, there's a common way of doing this that can be used by all vendors of different VIMs. The third component is this management and orchestration section. And this management and orchestration is mainly made up of VNF templates and network service templates. And this is mainly responsible for the lifecycle management of all of the end-to-end system. Again, we would need common interfaces. For example, we've got an interface between the management and orchestration platform and the VIM, another interface between the management and orchestration platform and the virtual network functions themselves. Another important interface from this orchestration is the northbound interface that goes on to the OSS, BSS platforms of different telco operators. The key takeaway here is that for us to have, for us to have a coherent virtualization framework, we need standardization of the interfaces from all the vendors, so that any vendor can deploy their functions in any custom, any off-the-shelf hardware. Okay, so if we look at the open source Mano project and where that fits in the context of the overall ETSI NFV architecture, the open source Mano project is all about the NFV, the orchestrator part, and the VNF managers. So it's this highlighted section in the dotted red. So NFV will so OSM will interface with different sorts of VIMs, some of the like OpenStack, etc. And it will also interface with the actual network functions that we have descriptors for. So the OSM is mainly the orchestrator, the VNF managers, and the different network service descriptors and VNF descriptors. We have a northbound interface from OSM that can be exploited by Telco's OSS and BSS systems. But in this workshop, we're going to show from the VICTORI project how this northbound interface is being exploited by multi-domain orchestration, as Kostas mentioned in his talk. So OSM, in summary, is it's an open source project. It's hosted by ETSI, and it's responsible for developing software stacks for the orchestrator and the VNF managers in particular. If we were to look at take a deep dive into OSM itself. It's made up of several modules. Again, it's a service-based architecture. You can see there's got a Kafka bus in there that is responsible for exchange of messages between the different modules. At the very front end, we've got an OSM client. And this is a command line client or the graphical user interface that you will see later on in the demonstration. There's a northbound interface, and this provides a gateway for external developers to interact with OSM. We've got the lifecycle management module, and this is mainly decomposed into two units. One is the resource orchestrator, which is responsible for orchestrating the active physical resources. So setting up virtual machines, interfaces, links, etc. And then you've got the VCA, which is the VNF configuration adapter, which performs things like day 0 operations and day 1, day 2, and day 3 operations on the actual VNFs. Of course, we've got the common services, and these are hosted in things like common databases, object storage, and some metrics for monitoring. So all of these together provide the overall architecture of open source Mano and how it's implemented in a service-based architecture. There are some key guiding principles that OSM has used, and there are lots of them. I've just highlighted a few for us today. One of them is having a well-known and common information model that aligns with the descriptions of ETSI NFV standards for the interfaces. And this model is particularly useful for how you define things like the VNF descriptors, the network service descriptors, the network slice templates, and network slice instances. So there's a clear structure of what the information elements are and what is contained in there. Once those templates have been defined, they are then sent down to the Vim, for example, OSM, and then the Vim in turn deploys these virtual network functions following the templates that have been described. Again, just like we had day 0 operations and day 1 operations in the IBM platform, within OSM, the day 1 and day 2 operations are performed using Juju chunks. So this is configuration of the VNFs and the links between these VNFs once the service has been deployed. So the key principle from OSM is have this common information model that aligns with the ETSI NFV standard, so that any other orchestrator that follows the same model would be easily integrated with OSM. The same with the Vim, if we look at the southbound interface of the orchestrator. Another important architecture principle of OSM is a unified northbound interface that follows this SOL 006 reference. And again, this is provide a unified way of how OSS and BSS platforms or external developers could interact with OSM over the northbound interface. It also provides a uniform way of describing the different descriptors, network service descriptors, DNF descriptors, etc. Okay, what makes OSM great is we've got 15 global service providers. It's an open source community, so it's free. Anybody can use it. You can download it and have a go at it. So it's a good starting point for anybody who's interested in orchestration. It's got the leading IT and telco providers working on it or contributing to the development of that. There are a number of VNF developers like Whitestack, etc., who are actively developing this OSM every day. Yeah, thank you, Kostas. With that, I have additional slides regarding VIMs, etc., but
I think we are okay. Thank you very much, Charles. Now I would like to invite Claire Caminat, Head of 5G Products and Partnerships, to chair this open discussion, and also invite Melissa and Kevin back to the screen. Also, Charles, you can open your camera again. Yeah.
Thank you, Kostas. Good morning, everybody. So very happy to welcome all our speakers for an open conversation around orchestration. I'm not going to ask them to introduce themselves because I think they've already done so. So we're going to jump directly to the first question. Quickly introducing myself, I'm head of 5G product and partnership, and I work I've got a business development and partnership background, and I work in the business team in Digital Catapult. So with no surprise, my first question is going to be around the business value of orchestration. So I know all of you have participated in your company in trials and prototyping and even live and at scale orchestration projects. So I wanted to know what's the business value for your customer and what have you experienced and seen? Maybe Melissa, you want to start on that?
Thank you so much. Yeah, I think the really interesting benefits that we've seen are not just, sort of cost cutting, but also the speed of being able to leverage things like orchestration. So whereas teams might currently need to, work quite closely internally to sort of get infrastructure provisioned for different applications or services that they want to run, there's no way for them to kind of go for like a self-service, off-the-shelf, ready to go infrastructure across, I guess, different types of compute that they have available or need. So I think that's the main sort of benefit that we've seen with our customers. It's not just cost cutting because you're using the infrastructure more efficiently, right? So you're dynamically scaling up and down. It's also just the speed internally of not needing to have, I think Kevin touched on this, right? Like not needing to have these dedicated big teams because it's such a specific type of knowledge that you need to be able to do this. So yeah, just really speeding up how those customers work internally.
Thank you. So it's cost cutting on the infrastructure and cost cutting indirectly on your staff also, because you don't need those big teams. And okay, Kevin, what have you seen as business value for your customers? And if you have real examples, also would be, I think the audience would be very interested in knowing this.
Yeah, that echoing what Melissa said, actually. So yeah, most definitely around not having to hire extra people. Can I build out the service once, and then if I'm going to scale it to 1,000 times that size, I want to scale it 1,000 times with the one person, not hire anybody else. So that's a massive saving, and that sort of drives those 80+% cost reduction capabilities in doing that, because you've standardized, because you're automating, and that's what people are very focused on, is on the cost cutting. You can't avoid people being focused on that. So that's where you're going to get the best metrics. But I think the customer satisfaction side is interesting as well, because when you do have these levels of automation and you're able to stay on top of those, then you get quite dramatic increases in those capabilities as well. Sort of 6 times resolution time, 6 times quicker in terms of resolving issues that are happening live on the network, because you've got the right level of automation, the right level of observability, which maybe wasn't there in the legacy world, because it was a piece of specialized hardware that was on a particular site that someone had to go and find and see. Now it's all virtualized and we're watching it in real time. We get better capabilities to manage it and fix things before they go wrong.
Yeah, very interesting. Thank you, Kevin. Kostas, maybe you want to add also something, maybe on the 5G project.
I would echo both Melissa and Kevin in terms that the biggest improvement will be in cost cutting, but the user experience and the ease of deploying a new service is quite important. So from enterprises and end user customers who are not familiar of deploying a new service or accessing advanced digital infrastructure like 5G and what we are building for the future, having the ability to deploy a new service very fast, from what it used to be several days potentially to what you can do in within some minutes with push of some buttons, that is quite important. And so the user experience would be one of the drivers for adoption of this technology.
So the business value in that case then is potentially a new source of revenue or acceleration of revenue if you're a telco.
Yeah, you increase your potential customers as well. So in the past, you would only target big players like mobile operators who had that knowledge of exploiting that infrastructure. Now your customer base expands.
Understood. And Charles, do you want to add something or you're mute?
Yes, Claire. I wanted to say that just to pick up on Kostas's point, the benefit of being able to set up to provision a service in the order of minutes instead of days. In the past, if you had to set up an end-to-end service, you'd require an engineer or a collection of engineers to go and configure each of these boxes, each of these specialist boxes in order to set up an end-to-end service. With the orchestration and virtualization, you can do all of this with a push of a button, which speeds up the time it takes you to provision a service, which means that you can provision much more services and scale out a lot quicker than you could in the past.
Makes sense. Thank you very much for Kostas, you wanted to add something? No. Okay, Alfred. Thank you very much for all your contributions. So my next question is a bit of again, a bit of a business question, but what is, in your view, the current state of the orchestration market in the UK? So how do you see the UK positioned for that, both, I would say, at telco level and at enterprise level? Melissa, I see you nodding.
Always nodding. This is a good cohesive panel. Yeah, it's really interesting actually that you mentioned UK. I think, we're obviously seeing a lot of this innovation maybe coming from the US or even actually in sort of Asia, APAC, we've seen tons of innovation. So, use cases or customers that are already deploying sort of multi-edge sites. That's kind of the deployment footprint that they have. And then orchestrating workloads across that is just something they want to streamline and simplify. I think in the UK, there's a lot of really exciting, exciting stuff happening really across multiple projects with different, I guess, areas of focus. But so we're working on a project with the Digital Catapult, 5G Vista. We're sort of more than halfway into that project. And I think something that's really exciting is, although we're looking specifically at streaming technologies, so FMBMS, et cetera, and the opportunities around that, the concept of, can we orchestrate a solution that multiple end users can benefit from a live event in a stadium, something that's really high capacity and high reliability that's needed. I think that applies to multiple different use cases. So as we see enterprises really scale up their, intelligent operations on a site, that's a lot of different workloads that you need to orchestrate. So, although things are running quite well now, it's, we're seeing a lot of experimentation with how they can streamline that through orchestration.
Thank you, Melissa. Anyone wants to chip in here or just
yes. So in the UK, we see a lot of private networks and testbed infrastructures being built, and there are several startups like Auri or Zeta Networks who are focusing on orchestration or slice management, which are elements of orchestration, and there are other smaller companies that focusing on that as well. So specifically for the UK and the ecosystem that is being built around private 5G networks and general 5G networks, there's a lot of demand for them. So there is a lot of opportunity for them to deploy and experiment with those technologies here. We see that also in other countries and across Europe. For example, open source Mano is one of the most used platforms, orchestration platforms, across all the R&D projects in Horizon Europe, for example. All, if not all of them, majority of them are using open source Mano. That gives the idea that enterprises and R&D organizations are converging in terms of standards or standardized templates around this across Europe and in the UK for sure.
Thank you. Thank you. So the situation is looking good in the UK. That would be my summary. Kevin, do you want to concur, or do you want to?
I do, yes. And I think that's there's a couple of things. I think we have really healthy competition in the UK, just with the core telco providers themselves. And I think we just have this culture of innovation as well, which drive this. And I have a global role, and I'm aware of other projects that we're doing in other countries and in other continents as well. And I think that we're looking at use cases which are more complex as well. I think we're trying to push it and drive it harder. So I think that's where we'll be successful. I like to have those conversations with my colleagues in other parts of the world and say that we're slightly more advanced than you are, or we've already done that. That's where that healthy competition comes from. It's inside me, and I think it's inside all of us in the UK, and that's what drives it.
Very good point. Nice to hear from a global player like IBM. So my next question is, how do you see the future of these orchestration solutions for the telco market and for the enterprise market? Maybe Kostas, with the particularly with the OpenMano solution that we particularly focus on. So how do you see the future for this?
The future is bright. As I said, in UK and across Europe, there will be more and more demand, both for automation of infrastructure that Mano systems like open source Mano, iOS platform, IBM or Auri will be using, but also the introduction of those private networks will have the demand or generate more demand for orchestration. We see a lot of companies, and one of the projects that Kevin and Charles are working, this Factor the Future, use distributed or require distributed factories to connect under a private network, which requires them the use of an orchestration platform, either open source Mano or IBM's platform or something similar. So the introduction and the market for private networks will increase the demand for orchestration in the next years.
Okay, bright future. Oh, Charles, you wanted to contribute to that?
Yes, I wanted to add it to add to Kostas's point, but from a slightly different angle. And this is mainly looking at from the Open RAN perspective. So with the introduction of Open RAN, or this Open RAN getting more and more common, you've got lots of these individual modules that need to be configured together. One of the key things that will help with the Open RAN will be the automation and orchestration of the different Open RAN modules. So in the UK, as you would know, Claire, there's this big drive for diversification, etc. And I see orchestration and automation in general playing a key role in that, because the more you disaggregate things, the more you need to actually orchestrate them in a unified way.
Fair point. Apologies in advance. I've got a young puppy at my feet that is being a bit boisterous, so you see me a bit like that. But I'm with you, Kevin or Melissa. Did you want to add something? Because I believe you also have a very good and a strong opinion on what's the future, especially for Auri or for IBM with this market. Maybe Melissa. Yeah,
I'll jump in. I think the opportunities are moving, or the opportunity is huge. So it's a really big sort of piece that we're tackling across the different sort of projects that you've heard of. But I think it's actually happening right now. I think it's something that's quite interesting. So it always seems like a future-looking technology, capability we'll have in a few years. We need to plan around it. Actually, it doesn't need to be a big, scary rollout or a huge cultural change. They're like small cultural changes around innovation that are happening right now. And I think that's something that people are seeing huge wins from, even on a small scale, and they're seeing how easily they can implement that across their businesses. So I think the orchestration piece as a whole is just a huge opportunity that's happening today and is a really exciting piece to be a part of.
Kevin?
Yeah, I think, and I mentioned it earlier, I think that the skills is interesting. I think, and there is this merging now of telco and IT skills, and having a focus on that is really interesting to track and think about as well. You know, if I'm a telco, I should be thinking about hiring IT guys, and vice versa. And how are we going to get these skills into the market over time, because we need them urgently? How are we going to teach this in schools and universities? You know, things like DevOps. So in the IT world, that is the thing you should be doing. It's quite difficult to get the right number of people that are doing it, and it's quite difficult to move large organizations towards that as a discipline. Now we need to do this in the telco space as well. So it's a really interesting time, and skills as a focus would be a good thing.
Yeah. This is definitely something we've seen in the many projects we've been involved in 5G. Skills, especially in enterprise, where these are the majority of our projects, where we've seen really almost the first hurdle was the skill when implementing a project. So hopefully we've managed to convince some participants, or all the participants on this panel, on this webinar, to start experimenting or start something around orchestration. So I wanted to ask you, what would you like to recommend as a next step if someone either working for telco or in the telco space or enterprise wanted to move forward with an orchestration solution? What would be your recommendation in terms of next steps, and also what challenge or pitfall you would like to highlight and they should be mindful about? Maybe Kevin, I'll let you start this time.
Yeah, thank you. Yeah, I think get yourself involved as quickly as you can in the technologies. You know, things like Mano as a starting point, understand those standards that are being created and how these components are being built, but also have that view, which I keep reiterating, of what's happening on the IT side as well. So, you know, what is containerization? What is virtualization? How are those things being deployed and managed? And I think the stumbling block to that, which I experience on a daily basis, is that it is not standardized. If I just simplistically get you to go and look at the 4 main hyperscalers and look at the way that they implement Kubernetes and implement containers, they are all different, which immediately means I need to have 4 skills. If I'm deploying to those 4, I need to have 4 guys with 4 different skills to do that. That's just wrong. That's why we have to have these standards, and we have to deploy these in consistent ways. So, you know, get yourself embedded in the technology. In the IBM world, we have a commercial offering. So you're going to have to find some money to use that. So start off in the open source world, learn those things. And when you get to the scale where it needs to be commercialized, then give me a call.
Thank you, Kevin. Thank you. Melissa.
Yeah, I think that's a really interesting point, actually. I think something that we've seen be really successful in a lot of the different enterprises we're speaking to is having the right sandbox environment to experiment as well. So as Kevin mentioned, you know, you want to be able to see, does containerization work for you? Is that the right approach? You need to have, I guess, a lot of flexibility around maybe wasting time, right? I think that's something that's really frowned upon, but that experimentation and exploring if, you know, this completely different way of doing things is a good fit for you is something that's quite important, and not being afraid to fail or realize that it's not the right fit. But you've learned a lot in the process about where, you know, IT is going. I think it's really important. And as Kevin also mentioned, you know, you shouldn't be having to manage all of these extremely complex things on a case-by-case basis for every infrastructure provider. You know, that prioritize simplicity at all costs, I think, and really standardizing the way that people deploy is quite important to us at Auri, obviously, because, you know, that's sort of the main pain point that we're looking to resolve is, you know, IT is getting more and more complicated. It won't get any simpler. And it needs to be, you know, really prioritizing that simplicity and seamlessness. It should be fitting into your business rather than being a big pain point for it, is really important. And I also wish that your puppy had been part of the panel, Claire, I have to say. But yeah.
Oh, thank you. She's very active. Costas and Charles, so what would be your recommendations if you had someone coming to you as next step and wanting to experiment with open manner?
I would say go for it. We have the testbed acceleration program that we run, either here at Digital Catapult or within generally the programs that we are running. So we have an open infrastructure that we can offer technical underpinned innovation. So meaning we have the technical expertise between myself, Charles, and the rest of the 5G team to explain and educate people who are not familiar with Mano, what it is, and get them a journey with them, and also then have hands-on experience with the infrastructure and the facilities in order to test and validate some of the concepts and potential benefits that they will see from a Mano system.
Very good, very good, very interesting. Yeah, I work for Digital Catapult, so I must say, yeah, amazing. Charles, do you want to add something?
Not really, just to echo what
Yeah.
Son have said. You know, if you could start off with the open source versions, so like the OSSM that we will show a demonstration later on. There's also another one which is called ONAP, which you can also play with and have a feel for. There are other orchestration platforms that come, for example, with OpenStack. So if you just get familiar with those, then you know, it's a good starting point. There are others in Europe like OpenButton, which are also a bit free to play with. So start with the free open source ones and get familiar with it, get familiar with containers and don't be scared of them, and then move to something more commercial grade.
And by the way, Charles, you're sitting in a Digital Catapult Future Network Lab. I can see the background. So that would be probably where all your experimentation and I would say evangelization, educational session would happen. No? That's one of our location, but it's still open for business. So we're coming to an end of this panel, and I really enjoyed it, and I have to say this is a very, for me, extremely technical, and you made it very clear, and it was very easy to understand for me. So I really enjoyed it, and I hope all of the participants had the same experience. So my last question is going to be just, you've got one sentence to tell the participants of this webinar. What is it? What do you want to say? What's your last message? Costas, do you want to start?
I would conclude with saying that management and orchestration platforms can make your life easier.
Yep. Kevin?
Standardize, automate, and run it well.
Make it happen. Okay. Thank you, Kevin. Melissa?
I feel like everyone's stolen my lines.
Yeah.
But I think,
I'm glad I went second.
Exactly. I was wishing I'd gone first for a second. I think Costas pretty much said it word for word. No, I think IT doesn't have to be a headache. It should be working with your business, not, you know, putting hurdles in the way of it. So, you know, orchestration is a key piece of that. That was more than one sentence, but I'm taking it.
Thank you. Thank you. And Charles?
Automation, automation, automation.
Okay. We're not even down to sentence now, we're down to words. So thank you very much, Kevin, Melissa, Charles, and Costas. It's been an absolute pleasure to welcome you on this panel. I think now it's time for a break. I'll let maybe Costas take over from me, and see you shortly then. Bye.
Yes, thank you very much, Claire, and thank you, everyone. We'll have a short break now, and we will follow up with the demonstrations from 5G VIOS, IBM Cloud Pak, and open source Mano. Hello, everyone. Welcome back from this break. I hope you had time to make a tea or coffee or grab some water. Let's move to the second part of this webinar with the live demos. As it was introduced, we have 3 live demos, first from Mark Rouse, our software developer on 5G VICTORI project on 5G VIOS, the 5G VICTORI infrastructure operating system. Then a follow-up from Kevin on the Cloud Pack, and finalizing with open source Mano demo. So let's move now to Mark. Let me stop sharing, and Mark, if you can start sharing and introduce yourself a little bit. Yeah.
Sure. Thanks, Kostas. Okay, let me just share my screen. So hopefully everyone can see my screen now. Yeah, thank you, Kostas. So in terms of the demo today, before we just quickly go into VIOS, I just want to outline some of the infrastructure that we have to help with a little video streaming app that we're going to demo. So we have OpenStack set up, which will help us deploy our virtual images or virtual machines. And we have 2 edges, both with OSSM deployed. And if I just quickly log into each edge, so hopefully you can see there's actually no network service deployment at the moment. For this video streaming app, we're going to have a client and a server. So we have one NSD on each edge. I believe edge 1 is the client, edge 2 is the server, or it's the other way around. We also have VIOS. I'm logged into VIOS, which sits in our Kubernetes cluster. And there's sort of 2 main concepts. There's the experiment and the edges. And in order to create the experiment, we need to register these 2 edges with VIOS. So if we go into the create edge page, now there are 2 options to register the edge. We can either upload a file in a JSON format, or we can manually fill in this form. Some of the things that we collect when we register the edge would be the name, the IP address, the port. We manually upload a catalog of all the NSDs. We collect some physical interconnection details and a few other things. But what I'm going to do, I'm going to use the file upload, and the file upload essentially captures the same sort of details that you see here in the form. So what I'm going to do is I'm going to register our 2 edges. So let's start with edge 1. Okay, and come back into here, and I'm going to choose edge 2. Register edge. Okay, so what essentially has happened here is we have a microservice component in VIOS called the API gateway. It's the external guardian, if you like, that communicates with all the edges. The edge gets registered with the gateway, and then the gateway contacts each edge. And the gateway will check to make sure that the edge is contactable. So these will turn online at some point. So if I refresh, okay, they will turn online. So what we can do now then is we have no experiments. So to create our experiment, again, we have a form that we can fill in for information. I'm just going to call it, a simple name. And from my 2 edges, so I'm going to select the client and the server. So this is essentially going out to another component in VIOS where NSDs are registered. And I'm telling VIOS that in my network service deployment, I want to include the edge and the server. So I'm just going to add an experiment. So let me just check with our edges. Okay, so they are. So the check at the moment is every 3 minutes, so they should turn online. So what we can do, if we come back into here, now if I click on the instantiate experiment. So this will go through a process of initiating the experiment, as well as then deploying the experiment if the initiate process works. So essentially what it does, it will go out to each edge, it will check that the NSD exists. If it exists, it will then move to the deploy process, which then actually starts to deploy the services to each edge. Might be an issue with edge.
Yeah, live demos do have those challenges.
Yeah, it was working yesterday.
Basically, what you would be able to see is the deployment of the network service on those two different instances and the two different edges. And by edge, we refer to a completely different autonomous network, meaning a private network that has its own Mano system. In our case, for both of them, we are using open source Mano to manage the underlying infrastructure. So I thought that at least for one edge of the two edges, the service was deployed. It was one of the second one that hasn't been.
Okay, yes, it's just told us it's initiated, but yeah, there might be an issue with the deployment itself. Oh, here we go. Check that.
Yes, just looking at one of the questions in the Q&A. The portal is based on the Genesis platform. We are using, as we discussed, three different ICT17 infrastructures: the Genesis, Vini, and Eve. And we add 5G UK facility as part of 5G VICTORI project. And we were using as much as we could in terms of already components from those facilities to speed up the deployment and development of VIOS platform. The portal, what Mark is showing, is based on the Genesis, but the slice manager or the experiment lifecycle management, they have been modified and they follow a different workflow, particularly for the interdomain and connectivity manager that we have developed in VICTORI project. In addition, for example, the introduction of profiler, which basically makes the optimal resource calculation for deployment. The second question was about deploying an OpenStack or Docker containers. It can be either Docker or OpenStack. That will depend on the capabilities of the Mano system. Open source Mano, since I think release 8 or 9, has introduced the underlying Vim also with Kubernetes. So you can, instead of using OpenStack, you can create your network service descriptor to basically deploy on Kubernetes. Similarly, there are other integrations with hyperscalers. So you can deploy, for example, in AWS instead of OpenStack. It is, as I mentioned, a matter of how your Mano system manages your Vim or interfaces with Vim. What Charles explained on those standardized APIs in his presentation. 5G VIOS is above the MANO system, so interfaces with the MANO system. So it's in the middle of between OSS, BSS, and MANO, basically.
Okay, that's now deployed. It's now up and running on both edges and in OpenStack as well. So look at, let's change this to 64. That's the IP address of my client. And then the IP address of the server is 44. Change that to 44. Reload. So what we're doing now, we're streaming a video from the server to our client. I don't know if you can see that okay.
Yes, Mark, it is
okay.
playing.
Let me stop that then.
So basically, the server is located on one edge, one infrastructure. The client, this web app, is located in a different infrastructure. There is interdomain service between these two edges managed by 5G VIOS, and the two services, the client and the server, have been deployed using open source MANO through two different OpenStack infrastructures.
Okay, so we've deployed our application. We can now terminate the application. We don't need it anymore. So we click on terminate. This should then send the instructions to remove our virtual machines. So that's been removed, and then let's just check in OSSM on the edge. So the application has been removed there. Application should be removed there. And we can delete the experiment as well if we want. And just another quick thing as well is when it comes to the edges, see they're both online now. So I delete edge 2, that should work. If I just create a quick experiment. I just select this edge because that's the only one that's registered. So because I'm using this edge in a experiment, there's an inbuilt check that should say, yeah, you can't delete this edge, it's currently active. So what I would have to do is, if I go back into my experiments, I should be able to just delete my experiment because I haven't deployed it yet. And I should then be able to come back into here, and now I can delete that. So I can add as many edges as I want. I can delete the edges if I need to. If I need to manage different edges, and same with experiments. I could have a record of all the experiments that we've run, or we can delete experiments. And that's sort of pretty much the end of the demo. I don't know if there's any additional questions that people may have.
Something to add here. We have been focusing on experiments as end user or use case application as part of the VICTORI project, but we see that this platform can be used not only to deploy the application functions or network services, but also the network itself. For example, with a containerized cloud infrastructure like your 5G core, or what Charles mentioned, the Open RAN components, they can also be instantiated using this platform once you define the service descriptor for that instance. And we know that OpenAir interface, for example, has been deployed, and we have tested it with open source Mano. So you effectively can deploy a 5G network using OpenAir interface, using this platform across multiple domains effectively. So you have your core or different elements of the core in different infrastructures, and they can be interconnected. This is potentially not the interdomain, but the ability to deploy OpenAir interface, the core network of a 5G system, to be deployed through this platform, something that we would like to test with the 5G Eve cluster, in the Alba Iulia and the Orange Romania group, because they are using it there.
I think the next demo is Kevin, I believe.
Yes, thank you very much, Mark. Kevin, if you want to present your...
Yeah, thank you, Kostas. And Mark. Right, just sharing my screen and hopefully you can see that. But yeah, so delving into Cloud Pack for network automation, so the offering that we have in this space for telco orchestration. So what I'm going to show is a couple of demos. This is not a live environment. I have pre-recorded this to step through. And this opening one is just a simple architecture. It's a voice over IP service. So just looking at this picture for the moment. So we've got some clients that are on the internet that are connecting into this service from the external network. We have a gateway, which essentially is a load balancer that this service comes into, and that's managing the traffic out to a scaling group on the back end of multiple voice over IP servers. So a pretty simple structure, but quite a lot of complexity underneath this in terms of the services that need to be deployed in order to enable this. And if I look a little bit at what the network architecture looks like for that, then basically there are three networks here. There is the internet itself is the external network, and a couple of ways in. So we have a Bastion jump host in this architecture as well to be able to log in and manage the environment. That comes in from the public network. We have the service itself coming into the voice over IP gateway. We have a management network, which is the green network behind this, which is connecting those management functions together for us to be able to log in and run this environment. And then we have the internal network, which is the blue network, which is connecting those services together. So three networks to be built. The voice over IP gateway to be built as a component, a cluster of servers for the voice over IP servers themselves. And then also we'll come across putting in a client as well. Just so this is a SIP performance testing tool that we'll introduce as a client as well to test the performance of this environment and its stability. So that's the sort of simple architecture. So as I described in my opening presentation, part of what we're delivering in this platform is the capability to design this service from a set of standard components. So in this view here, so this is sort of the service designer environment going into this assembly. This is what it looks like once it's been built. So it's using a set of components that are predefined for each of the capabilities. This is the entire voice over IP lab environment in this case. And then connected to that are the networks that we want to build and the relationships. If I click on this guy, it has a whole set of attributes which are gathered from the template that this is built on, and then you can customize that based on this particular instance. But generally, this is what a service designer will use to create this environment and set up the capabilities. So I'm going to just stretch this out a bit now so you can see it a little bit better. The darker lines on this are the actual physical networks that are going to be built. So dragging those out now. So we've got the 3 networks there. We've got the public network, the internal network, and the management network, which will all get built as we deploy this service. And then around those, we have the actual service components themselves. So those are the 3 networks. We then have down at the bottom, we have the shared component, which is actually the Bastion server. Sorry, the jump host on the top right is the Bastion server. We've got the gateway, voice over IP gateway component, which needs to be delivered. And then the voice over IP server down the bottom right here, which you see by this stacking behind it, is actually a cluster of services that need to be delivered. And then this share component is actually the firewall rules that are inherited by all of these components. So that's sort of the opening premise of having this service designer to create what you want to have deployed and what you want to actually run. Skipping on, if we then actually go and look at this being deployed, what we'll see is that there are instances of this that exist already. The state that they went through was a heal state, which is shown in the middle here, and I can run new versions of this to upgrade it or uninstall it or make it inactive. What we'll do though is we'll go into this and look at its structure. So this shows you from things that have already been delivered what the components were that were deployed and what their current state is as well. So this is looking at a running environment with its voice over IP infrastructure with all the individual components which are all running and active. And then what we also have in this setup, which we'll come to in a second, is the previous history of executions. And we can click on those and look at what happened. So this was the last execution that happened, which was a healing process. So it detected an anomaly and it needed to fix it. And when you do these deployments, you get this sort of Gantt chart view, which shows you how that was deployed. Looking at the history of this, we can see there have been 4 deployments of this particular service, the original create. And if we go into that one, we can see how that was actually deployed. So looking down this Gantt chart, so the swim lanes, the rows are each of the individual components. And what these service components have is a full life cycle embedded in them. So the complete definition of how they are created, how they are installed, how they are configured, how they're started, how they're stopped, how they're the configuration is changed, how they are uninstalled, how they are deleted. So all of those things are built into the template, and hopefully that's a template that you've inherited from the manufacturer. So if you're deploying a known component, hopefully those definitions have already been done in the standard way. You've imported them into your service design. And then when you do this deployment, what it does is it figures out the dependencies between these and then executes these functions in an efficient way. And we call this intent-based orchestration. What we mean by that is it's very similar and analogous to the SAP navigation system in your car. So, in your car, you want to get to a particular destination, you put that destination in. It will then analyze where you are currently and then use algorithms to decide on the most efficient approach to get from where you are now to where you need to be. This is using exactly that same approach. So you specify via the service design that we just created what the target state needs to be. What the system then does is it will then interrogate what the current state is. So if I'm building something brand new, there'll be nothing there. So it will know it will have to build all of this from scratch, and it will execute all of the installation and configuration steps to get you from 0 to the target state. But if some of these services are already deployed, then it will analyze those and find out what the current state is. So it may be, for instance, that it's completely deployed and it will find there are no changes that need to be made. or maybe we're halfway through a deployment and it was aborted for some reason. You can pick up from that point, analyze where the current state is, what things now need to be done to get us to the end state, and then I'll just operate those particular tasks. Hopefully what you can see from that is that this is what makes it valuable then for day two operations. So it's not just about orchestrating the initial delivery of the service, but also maintaining it. So I can run this same deployment over an existing installation to check that it's still compliant with what the service description was. Or if I just go and change that, because I want to upgrade it, I want to change the dynamics of it or some of the parameters, and then I redeploy it, it will automatically be able to figure out what the difference is between the current state and the intended state and just make those changes. So there is no scripting in this and there is no workflow. The traditional ways of approaching this is that you script this, create a whole library of scripts to do these deployments, or you use a workflow approach of designing workflows about how I make these deployments. This is not using either of those approaches. It's completely intent-based, and it's using current state and target states as the approaches to try and figure out how to get that done. So skipping on, this is a second component we want to deploy over the top of that infrastructure. This is the client, which is a performance testing tool for voice over IP, which will just put a load onto the network, and I can then use that to do some testing. So it's designed in a similar way. So this is the template structure, the SIP-Lab 6. It has a cluster of clients which will get deployed. And this is related to, and you can see down the bottom here, you've got the voice over IP instance, which is shown with a dotted line around it. This is referencing the production deployment that we've done before. So this is showing the relationships between those, and it's running on top of that service. I can then go off and deploy this one into the environment, and then that will go off and get created. So I'm going to create an instance of this. I'm going to deploy that over the top of the existing voice over IP capability that was built earlier, and that will go off and use the same kind of intent-based orchestration to get to that end state. Next thing to show you in this view here is a testing suite. So as I said in my first presentation, we're trying to bring that whole DevOps capability into this environment so that you manage these software components in a very similar way that you would any other kind of software. So this testing suite here allows you to define sets of tests, and it uses a sort of natural language approach where you create these statements about what things need to be done. So I start recording some metrics. I watch for particular capabilities in that. When I notice that a metric is over any kind of limit, then I want to scale that assembly out. I expect to see a successful scale out of the assembly onto this environment. I then want to sleep for a bit, and then I want to then run the opposite. I want to bring it back to the previous levels. If I go and run this, it now starts executing this test suite. So this is before I've rolled this out into production. I've done my service design. I've created this environment. I have my clients and my server infrastructure. I've deployed that, and I'm now running some tests on that. It shows you these tests running in live as this is going through. If I then go back into another instance of this environment, log back in again, I can go and look at this from a different view while that list of tests is being progressed. If I go actually into one of these labs itself to look at the current state, go and open up the execution of that, then we see live what that's actually doing. So this is what the Gantt chart view looks like when it's actually running live, doing a deployment, in this case, starting to execute the test. So it's doing a configuration at this point in time. So you can see these two different views. If we go back to This is the view in OpenStack actually of what is being deployed. So live while that's running, if I go and look at the network topology within OpenStack, I can see these instances being created, and these are the networks. Those colored vertical bars are the networks that have been created, and these are the virtual server instances that have been built by this deployment. Going back into the test suite, that's still running. And then we get to the end of that, and then that assembly has been built, and we see that we're progressing through this set of tests, and we see live that these tests have been passed or not. So it's just it's an interesting way of designing services, designing the complete test suite to make sure that everything is working before you go off and do a production deployment, and then just using this same capability of intent-based orchestration to roll out not only the infrastructure itself, but also the tests that need to be executed on that. So winding forward again, let's go and show a different capability. So slightly more complex environment. So let's look at deploying a 5G network slice. So this is a portal. So what we have in the tool, just pause there for a second before moving on. What we have in the platform is what we call the site manager, which allows you to manage multiple sites and the deployments that happen to that. It has a self-service portal capability. So in this instance, we're using that to create the demand for a 5G network slice. We'll fill in this form to create that capability. And we're choosing an EMBB slice, and we're going to do that for voice and live streaming and interactive gaming. We allocate that slice, which then pulls that slice out of the pool. And then it will go off and generate the lifecycle model, which is needed to do that deployment, which is now be available in the tool. And we'll go off and run that and deploy it. So inside the site manager, this is the structure that it created. This is just going to scroll down for a few seconds to show you all of the different parameters that were built. A very complex build which is needed for this, with all of the different attributes that are required to roll out this network slice. And then we can go off and this is the 5G part of that slice model, the 5G core part of that. Then we can take this service design, which is being created from that demand of the slice, and then actually deploy that. So in this next section, we'll see that being deployed. And then that live view again of the Gantt chart as it progresses. So again, using this intent-based system, so the service design shows what the target state is. It's gone off and looked at all the infrastructure that is required for this and analyzed its current state, and is deploying in an efficient way using the steps that it figured out from its algorithms to go off and create this entire environment. What I'm going to do for the last section of this demo is just show you what it's like on for the day 2 environment. So, well, now that we've rolled that out, let's look at the monitoring environment. So, going on to a monitoring tool, which is part of the platform, these are the metrics that are being managed and monitored. Go back to that view there in real time. And we're looking at the throughput there of those 2 slices. So what we can do is just let that run. We can set up metrics that are looking for service level violations. And what we're going to do and what we've done in this environment is use a performance tool to make one of the slices outside of the SLA, which in normal terms would mean that we need to scale up that environment to manage the higher load. in our monitoring tools, we see that that comes in as an event ticket. So we've got a problem. We've got a performance anomaly because with our throughput is being diminished because of not having enough resources to cope with the load. So what we have inside a runbook then for this, and this is where you start to use the automation to solve this. So our monitoring has shown us that we've got an issue. We've got an automated action that will scale up this environment using that same kind of structure that we saw for running the test suites. I can create a configuration that says, when I notice this kind of issue in production, where I have a service level violation in terms of performance, then the reaction I can have to that, an automated reaction to that, is to scale up the environment. And this is sort of the end result of that situation. So we noticed over time that we had this rising issue. In fact, we're out of SLA immediately because we turned the performance monitoring tool on and flooded this network. But then the system automatically scales up, and then we get back within the SLAs as quickly as we can by doing that remediation. And important to note that we're just using exactly the same process that we used for the orchestrating this service in the first place. All we did was change a parameter on the original model to say that the number of servers that are needed in the cluster is now an extra one, redeploy the model, and its intent-based system will say, well, the only thing that you've changed is that I need to up the that scaling cluster to another instance, and it adds the new instance. So in that way, we solve those issues. Normally, what you would do, this is a contrived example because I forced the SLA to happen. What you would normally do is predict these things. So use prediction algorithms in the monitoring environment to detect these things before they happen. So I see that my throughput or the amount of traffic on this slice is increasing over time. So I will preempt scaling up the infrastructure to avoid the problem from happening in the first place. That's what I wanted to show you today. So a couple of examples there. Starting off with this whole set of templates to do the service design, using things like Mano underneath the covers to derive those templates, building a service design itself that you want to have deployed, a full DevOps-based pipeline and testing suite to test that service before you put it into production. The intent-based orchestration then that will roll that out into production and get it all configured without any scripting, without any workflows. And then the day two operations where you monitor this using some great tooling around understanding the topology and understanding in real time what's happening in the environment, and then use that monitoring capability to drive change where necessary to remediate problems before they happen.
Thank you very much,
that's all
Kevin.
I wanted to show. Yeah, thank you, Kostas.
Thank you very much. A very interesting presentation and demo. We will move with the final demo on open source Mano. Satish Kumar from Digital Catapult will do this demonstration. Satish.
Yeah. Hi, Kostas.
Hello, Satish.
Yeah. Thanks, Kostas. My name is Satish Kumar, and I'm working as a network orchestrator, R&D engineer in Digital Catapult. So in this demonstration, I will show you how we can use open source Mano to deploy network services. So let me share my screen. So this is the open source Mano login page, and if we log in into it, we come this nice GUI comes, and where there are multiple tabs available to perform different tasks. For example, we can onboard network service package over here. We can onboard VNF. We can instantiate onboarded network service. So in this demonstration, I'm going to demonstrate a video streaming application And this this application is having 3 components. So one is obviously video client. And for that, I'm going to use VLC. So from VLC, we will request video. And from OSM, we will deploy 2 components. The first component is the router, and the second component is the content delivery server. So that will generate traffic and store all the videos inside it. And if we follow the principle of OpenStack, OSM, first we need to write the descriptor and packages, and that will be provided by the vendor. And then those descriptor and packages, we need to onboard it. So these 2 steps we have considered already is done. So like I have already onboarded a VNF package and linked that VNF package to network service. So if we open this VNF package, we can see. So in this VNF descriptor, we have written to deploy 2 video that will be deployed as a VM in the OpenStack. And these 2 video will be connected to internal virtual link. And for that, we have defined the subnet and the IP address for both the video. In one video, so here is the definition of video. In one video, we are going to start a kind of routing functionality that will take a request from video client, that is from video server, VLC, and then it is forwarded to video server. And for that, we are using Nginx as a second video. And these two video will be deployed as a to the OpenStack. So during the demo, we will see that one subnet will be created as an internal virtual link, and 2 VMs will be created. And first VM will be connected to management network, and from that we will VLC will access to first video or VM and request the video, and then the first router will then route the traffic to server. So we will see when the demo will start, all these components will be created here step by step. So before starting the demonstration and all, let me first start the video, and we will see the video will not work. So this is the URL to start the video, and if we start it, we will get an error and it's not working. And see, this is the error we get. So once the network service will be deployed from OSM, this whole setup will start working. VLC will request video to the first VM, and then that particular traffic will be routed to content server. So okay. So this is the definition of VNF. We can say VNF descriptor, and then that descriptor is then we have refer it to the NSD, network service descriptor, and here it is referred. So in NSD we can refer any VNFD or any number of VNFD, but for simplicity we have considered one network service and one VNFD that attached to each other. So now I'm going to network service package, and from here we can instantiate a network service, and we can give any name. So for example, I'm giving a name OSM demo and just the description. It's a video streaming application, so I'm just giving that. We can choose NSD from here because I'm already starting this particular NSD. It is already selected. And with OSM, we can register as many as VMs to OSM just to instantiate and choose a particular VM where we wanted to instantiate. These VMs can be of type OpenStack or Kubernetes. In this demo, we are considering OpenStack, and we are going to start the VMs inside OpenStack, but you can start it even in the Kubernetes, and for that you have to define VNFD as a KNF. So we have selected OpenStack VM, and suppose if here you can define or put your public IP so that you can log in into VM very easily without giving password and username, without giving any password. So for example, I am giving my public IP, public key. and then I'm going to create it. And we can see that here, the things, the resources we will start creating. So the internal virtual link will be created, is already created. And then we will see 2 video will be created and soon. So yeah, we can see first video is created and it is attached to management network as well as internal network, internal virtual link. And then the second video is created and that is attached to internal. So VLC will request to this VM to give a stream, and this VM will forward this request to second VM, that is a content server. And now if we come to the VLC player, so what the second VM is doing is that it's first downloading the video, which may take some time. And once the video will be downloaded, it will automatically start the content and start the streaming. So we can see in a few minutes. Yeah, both are running and video is started. So we can see once the both video is deployed and video is automatically started. So this way we can deploy very nicely and easily and fastly whole video application server end to end. So yeah.
Those reasons. Businesses that should get involved in this program are ones that are working.
So after that, I will show you how quickly we can also terminate the whole network service and delete all the information from the Vim, that is OpenStack, and from OSM. So if I go back again, and we can see in the OSM, the network service is running, and that is the operational status and configured. So what OSM is do is that because this whole end-to-end deployment takes a few steps. We in OSM world, we say day 0, day 1, and day 2 configuration. So in day 0, we deploy the video. In day 1, we do some sort of configuration if that is needed. For example, if we need a routing functionality from first video to second video, that may be done in day 1. And in day 2, maybe once everything is configured, if we want to make some modification after that, we can also do that one in day 2. In this demonstration, I'm only considering day 0 and day operation. In day 0, we deployed the videos and network service, and in day 1, the routes is configured from one video to another video within VNF. And now I am going to terminate the network service. And after termination, we can see all the resources that is available on OpenStack will be removed. So let's terminate and come back to again network topology. And you can see the things, the resources are now getting removed. And everything is removed now. So this way, like very easily with open source Mano, all the components and how open source Mano works, that is already described by Charles in the presentation. So we can see in live demo that we can easily and very fast deploy application service. That can be video streaming, that can be 5G core or any application. And we can easily also terminate it. So yeah, this is the end of demo. and we can see after termination, the video is stopped. Yeah. So that's all, Costa.
Thank you very much. And I would like also to thank all the presenters that give the presentations and the panel discussion earlier and the demos in the second part. So as a summary, I would like to tell a few words that what we can conclude from the discussion that we have today, that automation and standardization are key in order to achieve the benefits that all these platforms are set out to provide to the end user. So standardized APIs or information models like the ones that are used in OSSM or throughout, for example, the IBM's platform are required in order to make interoperability across different infrastructures. Because we have seen that the IT cloud and IT infrastructure is now looking more and more to converge with the telco cloud. And you have different vendors and different suppliers, from big names and hyperscalers that they have their own ecosystem around them and their own standards, and then smaller players and R&D organizations who would like to use some open source implementations for initial testing. So this simplicity and experimentation with open source would be the first step to go from 0 to let's say to 10, and then move when you want to scale with more commercial offerings. We see that open APIs are required in order to make this interoperability work, in order to also to not to have openness, but also accessibility. You need the service providers and the custom end user customers would require this single pane of glass to view what's happening in the infrastructure, to troubleshoot it as easy as possible. And this visibility potentially may introduce new risks in terms of security. That's why, for example, data locality is important parameter for enterprises, particularly enterprises. And that's why private networks and edge compute will, and it's my view that will flourish in the next couple of years. But we see that, as Melissa mentioned, don't wait for that to happen. Come and experiment as soon as you can, small steps. Digitalization is not a turnkey solution for everyone, that you will transform everything from the start, and you need to do small steps into this, I would say, marathon of digitalization and that you have, and transformation, digital transformation that some of the enterprises will need to shift to. And in all that digital transformation, remember that these different orchestration platforms are available, and they will help you to make this transition and manage your underlying infrastructure simpler, faster, and more importantly, more cost effective. And we have seen from Kevin and Melissa that the numbers do add up, and you will potentially have big savings in terms of your costs, and both running costs and CapEx in some cases. So thank you all for joining this webinar. Please join us to thank all the presenters and join the newsletter that we have. Thank you all.